love coffee. I'm definitely not awake enough in the morning to be pouring scalding hot water over grinds like this person. But this little coffee maker, and all coffee makers, are basically a filtration membrane. Coffee grinds and water enter into the filtration membrane, and only water and the lovely essence of your coffee leave into your coffee cup. The same thing's happening into the kidney. Whole blood is entering into the kidney to eventually, and let's label that, there is whole blood here in this interlobar artery. And whole blood eventually curves around a medullary period in an arcuate artery, and then it perfuses up into a cortical radiate artery that then feeds many renal corpuscles, giving the blood up to be filtered. At that point, there are two filtration events that are going to separate waste products from the whole blood. The filtered whole blood is then going to return to circulation by way of probably this venule here, right? This is filtered blood that ends up leaving the kidney. And the waste products leave by way of urine. And this urine weeps from this renal papilla, which is just the tip here of the medullary pyramid, and it weeps into a minor calyx that then is collected into a major calyx, the renal basin, with other urine, and then descends the ureter to the bladder to be excreted from the body. Let's try to put all these parts together and in perspective, which is not easy. This that I have pictured here is one medullary pyramid with blood vessels and nephrons and a collecting duct. Blood comes in by way of the arcuate arteries. They curve around, hugging the border between the cortex and medulla. The arcuate artery and vein are on that border of the cortex and the medullary pyramid, and you can use this as a landmark in other pictures. I've placed a few nephrons coming off of one cortical radiate artery, but please understand that there are numerous nephrons coming off of one cortical radiate artery. You may have many cortical radiate arteries in one medullary pyramid, and you have a few medullary pyramids. So you have a lot of nephrons. A lot. Right now, I want you to be concerned with these two parts of a nephron. The renal corpuscle, which are these two bullseye things here, and the renal tubule, which is the rest of the yellow on this diagram. The renal corpuscles are these knots of capillaries surrounded by this little cup that the nephron makes in that area. These renal corpuscles, they're all in the cortex. This is all cortex. This is all cortex. Renal corpuscles are always and always and always all in the cortex. You can see them all in this microscopic picture. Deep to the cortex is the medullary pyramid, which is just made up of tubules. So this is the dividing line here. This is cortex that has those renal corpuscles, and this is medulla. And whether it contains these loops of the nephron or this collecting duct, it's all tubules that dip into the medulla. A nephron consists of a renal corpuscle and a renal tubule. Both of these things are discussed in more detail in other mini lectures, but let's just look at the half macro micro anatomy here. A nephron contains filtrate, not urine. Filtrate is still in the process of exchanging with the capillary bed. No matter what type of nephron we talk about, the renal corpuscles are always in the cortex of the kidney. Always. always in the cortex of the kidney, no matter what kind of nephron. The renal corpuscles are basically just serous membranes surrounding a fenestrated capillary called the glomerulus. In both types of nephrons that I have pictured here, the renal tubule drains the capsular space of the renal corpuscle. Urine then travels through these tubes of the nephron, and they connect to a collecting duct, which drains many nephrons, as you can see here. The collecting duct, along with other collecting ducts that are in that same medullary period, they all weep urine from this renal papilla that collects in the renal basin and ultimately descends the ureter. Cortical nephrons do not dip into the medulla. They give them that name, cortical. I mean, they dip a little bit, but hardly any bit, right? These other ones over here, which are called juxtamedullary nephrons. These are nephrons that dip deep into the medulla. And in fact, these are the nephrons that save your life in times of dehydration. You use cortical nephrons all the time, always. You will employ the use of juxtamedullary nephrons if you become extremely dehydrated. So they don't work all the time. They're kind of employed when needed.